In this lecture, you will learn about a nice optimization technique that arises automatically from the ability to use functions as data and from writing pure functions. Imagine you have an application that does some CPU-intense calculations and, using a profiler, you find out a main performance bottleneck is located in one single pure function. Your code needs to call this function over and over again in different situations, in many cases with parameters that were already used to call it at some point in the past. Let's have a look at a minimal example for this. Your first intuition may be to write a cache data structure, something like a dictionary that you can use to store the mapping from input to output of past function calls. Every time you call the function, you would first look into this dictionary if the result to this input is already known, and if so, use it instead of calculating it again. And this is a very good idea. The only downside is that all this cache handling will distract the reader of your code from what is actually going on. It would be much nicer to be able to hide all this stuff into a lower level of abstraction. Okay, that looks great. This is a good point for you to pause the video and ponder about how Memoize could be implemented. Okay, since you are back, let's have a look at one possible implementation. All the dictionary handling stuff will be hidden in a closure, making your actual code very concise. We only have to write a function that handles the caching once and then can use it to memorize whatever function we want. The only thing you have to watch out for is memory consumption. If the input or output types of your function take up much memory, this of course will be reflected in the dictionary inside the closure of costly function memorized that will grow over time.